seriously. Yes. Okay, not here. That's done. So that is done. Yeah. This is also done. One more thing. Okay. Rust gets me a few followers, but I'm not going for followers. So Rust doesn't give me that language. So let's go for this. Okay, this is the chapter, and I'll be writing a few notes here. The control flow. Yeah, so the thing here is that we have something called as the crafting interpreter. Let's added a few things here. We have also ignored a few things here. Commit in files created and updated till chapter 7. It's 8. Yeah, that's what I have done. So let's play some fucking music on. I have a few good collections of music now. Ah man, not Pratik Kuhar. Pratik Kuhar is a good guy. He was a great guy, in fact. Somehow the music's not playing. What is wrong with Spotify? Spotify, come on. Better from you. Okay, something might be wrong. Right. So Spotify site is a bit of slow, dumb thing that loads, takes a lot of CPU memory. And also I have a thing, the timer that I built in nim. Oh shit. So, oh shit. Really? Yeah, that's, and that does the work. Good. Really? Okay. Yeah, I think third 120. Cool. So song is not being played. Let's play this song. Yeah. Now that we have the song playing, you wouldn't want to listen to me too much. I'm increasing the volume of the song. Just tell me if you are disturbed by the song. My invisible watchers. Yeah, sorry for the tour. Okay. We'll write. Okay, sorry. One more thing. There's one more thing I have to do. Okay, commit is done. Git push origin master. That's done. Master. Really, man. That main thing. Fuck, anyways. Nobody cares. So, this is done. I think we have a readme here. Yeah. I'll go over this readme now. Now we have this readme. Let me add. I have no idea how this whole thing readme thing works. Vim readme extern. Really? So nvim not okay, sorry. Font. Did this come? Okay. So I think we and this is folding. So it's reducing for us over the buffer. Opens all fold. Let's see if that works. Now folds up the folder. Now concealing the set bold and like this and that. Okay. Now let's conceal text with other text. Okay. Now concealing is set. Let's now help conceal cursor. Help conceal cursor. The mode, normal mode. We have something, text is on normally 0. So I think we have full. Yes, full folder conceal conceal level, conceal cursor and everything. I'm not sure what's the cool thing. So I'm not. Number to 0. Goal 0. Let's see. Not an editor command. Syntax concealing. Yeah. So I have this set conceal level to 2. Conceal level to 2. We have something that's not concealable. Following named actor. Really. Who? Does that work here? Level equal to 0. Oh, that works. This is much better, I guess. Yeah, does it work? Yeah, no. I did the mistake. Okay. So we have this grammar here that's running. Whatever the code is. Okay. Now next, what do you have here? No people. Okay. Now conceal will not work as expected. Not work. Okay. So compared to last chapter, this is easy. Turing machines. In the last chapter, mathematicians stumbled into a series of confusing paradoxes that led them to doubt the stability of the foundation they built their work upon. To address that crisis, they went back to square one. Starting from a handful of axioms, laws against shared theory, they have to build mathematics on top of an impenetrable foundation. You want to rigorously answer questions like, can all true statements be proven? Can we compute all functions that we can define? Or even the more general question, what do you mean when you claim a function is computable? Okay, so they hope the answer to the first two questions would be yes. All that remained was to prove it. Turns out that the answer to both is no. Astonishingly, the two questions are deeply intertwined. This is a fascinating corner of mathematics that touches fundamental questions about what brains are able to do and how the universe works. I can't do justice here, author says. What I can do to note in the process of proving that those questions are false, Alan Turing and Alan Church devised a precise answer to the last question. Okay, so the both is no. Okay, the Turing machine. Okay, they each craft the slightly system with a minimal setup, powerful enough to compute any last class of functions. These are not considered the computable functions. Turing system is called a Turing machine. Okay, Church's is the lambda calculus. Both are still widely used as the basis of modern models of computation. In fact, many modern functional programming languages use the lambda calculus as their core. Okay, cool, nice. Turing machines. Okay, my song has stopped. Okay. Oh. Cool. Since Turing proved his machine can compute any computable function, by extension, that means your language can too. All you need to do is transfer the function into a Turing machine and then run that on your simulator. If your language is expressive enough to do that, it's considered to be incomplete. Okay, that's pretty dang simple. So it doesn't take much power to do this. You basically need arithmetic, a little control flow, and the ability to elevate, and you take a look at this. We have got the first, but the end of the chapter you will have the second. Okay, nice. Control flow, if and else. Conditional execution. By enough history, let's judge our language. Yeah, cool. We can divide control flow roughly into two kinds. The first is conditional or branching flow, and looping. Cool. Branching is simpler. We'll start the C-derived languages that have two main conditional if and else, and the perspicaciously named conditional operator. Okay, so oh fuck. And if statement lets you conditionally execute, and the statement and conditional operator lets you conditionally execute expressions. Logs doesn't have the conditional operators ternary, which I implemented before. So let's get our if statement going on. So let's write the if statement. It gets a new production under the statement grammar loop. Okay, nice. So we are writing here. Let's see the grammar here. So this is our grammar. Statement. Where is statement? Yeah, statement gets a XPR statement, if statement, and a block statement. Okay. Statement and a block statement. So what is an if statement? If statement is something if so this is how if statement looks. Operation and we have statement. Okay. And we have statement so Okay, so we have a statement. If expression, we have statement and okay, the statement may be blocked or non-blocked. Ah, nice. And then we have something in on the else side. Else statement. Okay, else if is not there. I see. Okay, this is conditional, obviously. Oh, nice. That does do good for us. You know. Nice. Now the semicolons and the rules are quoted, which means they are part of the grammar. Okay. Okay. The rules are quoted. That's nice. Because the rules aren't quoted, which means they are part of the grammar meta syntax, not blocks of syntax. A block doesn't have a, this one at the end. An if statement doesn't either, unless, but then or else statements happens to one of them. In a semicolon. Okay. If statement has an expression for the condition, that then a statement to execute if the if is truthy. Optionally, it may have also have an else, which is true. The syntax tree node has fields for each one of those pieces. So yeah, fuck, we'll be generating AST again. This generation thing I do not like, but yeah, it has done a lot good than bad actually. I mean, somehow I'm not using macros. The macros would have allowed me to do this faster. But yeah, that guy is like expert in Java. I'm like starting out. Anyways, we'll be implementing the Java part first. Where the fuck is this? Yeah, there you go. This is the Java part. It works actually, to be honest. Okay, so this is generate AST and main. We have something in the if part. Okay, I didn't write this very nicely. Things because come on now. That's bad. Okay, this AST will be defined here. Okay, this is just a statement, right? Okay, we have condition the branch, else branch, the branch, so then branch. Yeah, that seems. If the building of. So. Okay. Get generate output. That's it. We're done here. Now that we're done. Okay, so somewhere down the line. Output directory dot base directory. Not sure if things went all right. Oh, see. Base name. What's the base name? STMT. Output directory is interpreter. Ooh, that cannot be the same, right? Okay. Okay. So we are done with the bullshit. now that we're done, we can write this in. I think I can write a script for this. I do not fucking know how this works. So we go source main Java interpreter interpreter yeah, that's it. Then Java okay, we also go into tool. Cover. We go outside. Then add this. Okay, so that should do the work. Also, let's go a bit outside now. We are in tool main. Okay, one more I think outside would do. So yeah, generate. Okay. JSS permission denied. Let's do the sudo thing. Fuck. Huh. Okay, command not found. Okay, generate. That's done, I guess. Cool. So we have something on the parser. Statement. मतलब मैं तो अगेंस्ट में भाई बैन करो भाई इसको. So what we are doing here, statement. So yeah, first we take the param, then condition, express that. It's always an expression. Second, we consume the right param. Oh shit. Or if it's not there, obviously. I mean, it makes sense, right? So if it matches else, then branch. We have a statement. Statement may be a branch or not. Cool. Then we have else branch. It's statement else branch. We have statements that we're making. New dot if condition, then branch. Okay, so we are done. Okay, that half useful. You need some kind of delimiter between the condition and the then statement. So the parser can tell when it is reached the end of the condition and expression by the. So he could use this one as the ending delimiter without having unbalanced parentheses. Low and some basically use keyboard like then as the ending. Don't have anything before the condition. Go and see if instead require the statement to be brace blocked. That lets them use statement to tell when a condition is done. Parsing code hews closely to the grammar. It detects an else clause and looking okay else and this one. If there isn't one, the else branch field in the that's seemingly in a consider this. Okay. So here's the riddle. Which if statement does the end clause belongs to? This isn't just theoretical question about how we noted our grammar. It actually affects how the code executes. Okay. If you attach the else to the first if condition, then when false is called and false is fallacy. Regardless. Since else clause are optional, there is no explicit delimiter marking the end of the coming. So this is called dangling else problem. Okay, it is possible to define a context-free grammar that avoids the ambiguity directly, but it requires okay. Now, instead, most languages and parsers avoid the problem in an ad hoc way. Instead, more languages and parsers avoid the problem in an ad hoc way. No matter what hack they use to get themselves out of the trouble, They always choose the same interpretation. The else is bound to the nearest if that precedes it. Our parser conveniently does it already, since if statement eagerly looks okay. But the problem in ad hoc way, no matter what hack they use to get themselves out of the trouble, they always choose the same interpretation. Nearest if. Okay, else is bound to the nearest if. So the second part is true. Cool. I also thought that should be the thing. Since it was statement. Okay. Syntax in hand, we are ready to interpret. Let's get ready to interpret. So now we have visit statement. I think we have an error here. This is for interpreter. Cool. So okay, let's implement it. Visit if statement. What does it do? So ours is like if is truthy. Now when did this come actually? Is truthy is there. Surprising. Okay, insert, execute stmd.else branch. Okay, this is means it's nullable. What's in the void thing? Okay, anyways. So visit if the void thing. If you followed this same self Java code, because the company is put in the response, otherwise compare the code to how the interpreter handles other syntax we have implemented. The part of that makes sense especially is that Java is if statement. Okay, most of the syntax trees always evaluate the subtrees. Here we may not evaluate the then or else statement. Either of those has a side effect. The choice not to evaluate it becomes visible. That's cool. Logical operators. Now we have logical operators also. Since we do not have a, you might think that we are done with branching. No. Even without the ternary operator, there are two other operators that are technically control flow constructs, the logical operators and then or. These aren't like binary operators because they are short circuit. If first one is false, then forget. We know what the result is. The expression must be, we don't evaluate the right operand, for example this one, and for an AND expression to evaluate to something truthy, both operands must be truthy. Okay, we can see this one is left. Okay, let's say Okay, cool. Assignment and equality. Okay, so we make a few changes. Assignment. So we had the logical or. I mean, then. Okay, is that high? It's not higher than comma, I guess. So I think we have to. Is it higher than ternary operator? Okay, it's lower than ternary operator, so that means I have to replace this and in place of logic or logic and or logic and. Okay, we have it here. Also. Logic and okay, logic and or evaluates everything, so it's basically okay. Quality and obviously, and so we have also equality here. Now what is actually interested in name? This is true. Now for ternary we go into this one. We just okay. Quality assignment now cascades. What's it called? Okay. Similar to. Circuit, that's a semantic concern. Okay, syntactic concern, not a syntactic concern. Cool, no problem at all. Let's sure this happens. I'm just fixing my microphones. My headphones are that. I mean, yeah, they meant to. Sure, like they go for 6 hours and max full time listen. 6 hours is a lot, but yes, I like to have more. I loved more, in fact. More than 16 hours. So yeah. So that's a semantic concern, the short circuiting, and we have here, we have to change the thing again. Generate AST, that one, Okay, so what do we have here? Logical and this one. Oh. Okay, we have literal and we have logical, obviously. It's an expression, right? Logical expression left, token operator, expression right. Okay, that's done. Now, logically, it's done. So we've the new expressions into the parser. We have to change the parsing code. So this is in the parser. Parser. No, yeah, that seems good. We have to change the parsing code. So that's in the assignment. Okay, assignment has got equality. So this changes, I guess, or comes into play. So where is the or then? That's what you might be asking. Yeah. So we play a few things here. We also have and, I guess. Okay, and then now we done null, obviously. Okay, that's cool. So we have or. What does or does? Or does a trivial thing. Let here equal to n. Well, match or now token operator queries. Right, XPR, XPR, logical, XPR, operator. Okay, so we have some logical things shit going on. Now, why is this logical? To a type. Okay. I'm not sure if this logical comes into play. Okay, there is no logical actually. Okay, so but I didn't fucking run that thing. Okay, sad. So all I had to do this. That's it. That's it, my boy. Yeah, we do have logical now. Yeah, cool. So we return back here. Now for and it's almost the same. And we copy this. It's almost the same. What we do here is, but we short circuit the thing here, or previous and AND. How do we short circuit this thing? Okay, that has to be dealt with. Now logically we have And is there match and previous and oh equality. Okay, we do not handle this thing here. That's okay. Equality for its visit logical operation. That's in obviously interpreter. Now when we visit logical operation, public void visit logical expression dot logical. Yeah. Now what we do is that we first evaluate this. Evaluate left. If left is true, do not evaluate the right. That's it. Oh, I think that was or. Okay, this is or if is truthy. Okay, so left is being okay object. So if it is an or, return left. I didn't get it. So first to evaluate the left. Expression dot left. We have expression dot left in end. Evaluate that end. Now if the left is evaluated, operator dot type equal to or. Oh, okay. Logical has just one thing, or an end. Okay, then return left. Is truthy left, then return left. Okay, cool. Miss truthy left. Else, okay, this has been summarized quite nicely. I mean, oh, this guy is awesome. Yeah, cool. Actually, he has written the code before and we optimize this stuff. The visit binary. Let me write this nicely actually. Or if it is truthy, else evaluate, else return. Return evaluate expression dot right. It's true. That's nice. There's no need for actually, to be honest. Okay, just wrote this at the end. I'm not sure. Okay, this is just a conundrum of this thing. Cool. Now we have this. If you compare this chapters with binary method, you can see the difference. Here we evaluate the left operand first. We not then do we do deciding what actually to return value to return. Since locks is dynamical type, we allow operands of any type and use truthiness to determine what each operand represents. So yeah. We apply similar reasoning to the result. Instead of promising later true or false, we are Okay, a logical operator merely guarantees return a value with appropriate truthiness. Fortunately, we have values with proper truthiness right at hand. The results of the operands itself, so we use those. For example, this one, I and the S. Okay, that's cool. The first line, high is truthy, that covers up all of the branching primitives in logs. Let's read to jump ahead of loops. You'll see what I did there. Jump ahead. Get it? Okay. See, it's like a reference to forget it. Go to. We had go to. Go to shit. Anyways, this is done, I guess. I will not experiment with it much. I will not even experiment with this much, actually. To be very honest. We have a few people here. So Camilo is here. If Camilo, you are not a bot, do contact. Frustrated by all this bot coming in and saying about nothing. So Camilo, are you a fucking bot? You have no followers. There's a chance you do not have. You aren't a bot. So cool. Hard fault handling. Okay, you guys, you haven't done anything. Cool. So if you want to put some message, I mean, do feel free to. I'm actually streaming just for the fun of meeting people. Actually, that's the one thing I'm streaming for. So yeah, if you want some interaction, if you want something to do, he's off. Camilo is off. So cool, no problem. Let's continue with our code now. Whereas was, yeah. Hey Juan. So I'm writing some Java code right now. How are you, man? I mean, you should actually, not just you, everyone should actually do this book, Crafting Interpreters. It's a lot, there's a lot you can learn actually from this book. I mean, writing a compiler was, I didn't think it was that easy. I'm already in if and else, next is while loops. So yeah, I never did that actually, you might have done it, I don't know. Statement, so have you tried the restream I have seen on the board? Yeah, actually I tried restream, and so I am on YouTube too. But the problem with YouTube is I was not able to turn on my, what should I say, chat option. So that was something of a disappointment. Yeah, let me see where it was. My channel. I have nothing in my channel, YouTube Studio. Yeah, it's going on right now. So chat is disabled here. That's not a good thing to have. Okay, chat is not disabled here. Really, someone might have put something here, but okay, anyways, let's also put pop out chat. Cool. Can I minimize this? Nice. Let me. Yeah, maybe. Okay. So let's put this here. I mean, multi-screen is a bliss, man. I love multi-screen. to be honest. The Restream is a nice service. Yeah, it's a nice service, man. Really nice service. I like the service actually. So we have a few participants. I'll show you how my whole thing looks now. Actually, let me show you this whole photo. Where was I? Images, I guess. No, not images. Documents, home, pictures, screenshots. Yeah. I think the current screenshot is this one. I guess. It took the screenshot of this. What the fuck? No. This is the one. Really? Oh, okay. Yeah, now I've got it. Yeah, so this is my setup right now. Obviously, I have NVM running here. Two YouTube things here. YouTube and this. So if someone comes up, I mean, cool. That's it. Let's close this shit anyways. Closing this. Now we are in while loops. So this guy makes a while statement, sorry. Now this thing, if statement and while statement. So did you have a computer science major? I mean, did you have a computer science, or are you self-taught? I am actually self-taught, so learning this is like quite fun. Oh, nice. So how did you get into programming? What's your story? You're from Argentina. Lionel Messi. I'm a big fan of Lionel Messi, by the way. I'm a big fan. I mean, I had what should I say? Lionel Messi poster in my dorm room in university. Big one. So ever been a fan. So I also watch Argentina football matches because he plays. Still a big fan of that guy. Cool. So yeah. Anyways, I was like, how did you learn programming? I mean, how did you get into? You said you are 10 years into programming, man. That's a lot of time. Self. New grammar rule gets its own syntax. Generate AST. Okay, I have to again generate AST. More Java code coming. Yeah. Now that's the Java code we'll be writing. I think it goes here, right? No. It doesn't go here. So we have where, I guess. No. While. Condition stmt body. Yeah, it's auto formatted, so cool. While is done now. This is a very nice thing this guy wrote. Okay, while is done now, writing the same thing. Oh, anyways, what was I saying? So tell me more about yourself, man. I mean, I have talked about. You have seen me do everything. You have seen me do everything. Like, tell me about yourself. It's been some time since we are all good friends. So you are from Argentina. That's all I know. You love Nim. You love Python, obviously. Now, parser.js, Java. We have in statement. No, not like that. Hey. Okay. Are you there? Mm-hmm. Well, I think you are not there. You have gone. So we'll be writing a few things here, and one of those first things we'll be writing is a while statement. After while okay. Condition right condition expiration. Just chilling and quarantine. You can go places now. Summer is coming. Just coding at home. Summer is coming. Really? Oh, you are in the southern hemisphere. Fuck, man. It's it will start getting cold here, man, in India. Summer is gone. I mean, right now I'm wearing a half t-shirt. So after a few days, I will be wearing a jacket when at home. So yeah, that's about it. So we will be writing where while condition will be taking a condition in a body. So did we generate the class? No, we didn't. We have to. Boom, done. Oh, sorry. I guess this works. Did it starting? Yeah, Xmas is hot here. Still, all Xmas decorations have snow in it. Oh, are you a Christian? I mean, by religion, or you are atheist, or what do you believe in? Atheist. Ah, okay. Cool. We have something here in interpreter. Atheist. No. You don't believe in God then. Cool. Mm-hmm. That's cool. I used to be an atheist, so I do not care much about who does what. That's one thing. I personally am not atheist right now, but I have my own reasons for that. I think I am atheist. I don't know. I mean, if you can categorize atheism, so yeah, while statement is very simple, is truthy. Okay, while statement is much like the real while statement actually. Oh, no problem at all. Now that does the job. The while is covered up. So do you watch football? What do you watch actually? Football and something. For loops. We have for loops now. Okay, let's see where can we put this for loops here. You can put the for loops in statement. Yeah, for loop is a particular statement. For statement. A fan of football. I'm not fan of football. Really, man. I thought all Argentinians are. Sorry for the stereotype, but I thought, yeah, like all South Americans actually follow football. People are. Yeah, exactly. So, in South America. Where are you from exactly? Buenos Aires is your capital, that I know. Ah, Buenos Aires. I mean, I almost know all the capitals of the world. You can do a quiz on that. I won't even cheat. Almost all, but not all. I don't know. Many of them now. When I was a kid, I used to remember those. Asado. What is asado, man? BBQ. Ah, okay. So, this is beef, I guess? No. Lettuce, tomato, onions, vegetable. It's a bread. It's a bread mixture made of potatoes, corn, onion, eggplant. Cooked on the grill and seasoned with olive oil and salt, beer, wine, soft drink, and other beverages. Common. Okay. Nice. It's not. It's vegetarian. Completely. I mean, veggie food. No non-vegetarian food or like animal product. Asado way. Nowadays, there's even vegan asado. To be here, man. Let me see what asado is. Looks tasty. Okay, steak. This used with beef. Beef is kind of banned in my country, not in all of the states. In my state, it's not banned, but people do not eat beef in my country. They can eat all other meat. The cow is considered to be a sacred animal in India. A lot of the Hindu people actually consider the cow as sacred. So yeah, I do not eat beef. I won't even eat beef ever, even if you offer me to. I mean, I do not know. I have never faced that situation, but yeah, I won't even have that. Not due to religion or something, but just haven't had beef any day. So yeah. Anyways, back on this track. Shit. Come on now. Okay, that does the work, I guess. The vegan asado, okay. It's not always cow. People make a lot of stuff as asado. Pig chicken, yeah, pig chicken. Pig is, I mean, pork is very awesome thing. Rabbit, etc. Yeah, I've had rabbit or what? I don't know. I don't know. Goat and chicken is very popular here. Pizza is also real nice here. Pizza, okay. Pizza is even real nice here too. Most modern languages have a higher level looping statement for iterating, but arbitrary user defines sequences. C Sharp has for each, Java has enhanced for, C plus has range based for. Is of a cleaner syntax than C's for statement by implicitly calling into an iteration protocol that the object being looped over supports. Those are great for locks, though we are limited to building up the interpreter chapter at a time. We don't have objects and methods yet, so we have no way of defining an iteration protocol that for the for loop could use. So we'll stick with the old school C for loop. Think of it as a vintage fix C for control flow inside the so you should actually try biryani. Biryani is a common dish from India. I'm a big fan of biryani. It's very spicy, but if you can eat spicy only, then you are supposed to eat biryani. So yeah, it's a non-vegetarian food. I mean, animal product uses. This is biryani. Ah, it's a very tasty thing, man. I love it. Second Indian food that I love is chili chicken. I think you won't find chili chicken there. Chili chicken is a very popular dish here. So it's very very spicy. It's ultra spicy thing, man. But I love it, man. Even the photos is giving me shit, man. I'm not going to watch this. Getting hungry. Fuck. Have you had Indian food before? Yeah. Mm-hmm. Okay. Most modern languages have high level expression in this. Inside the parenthesis, you will have three classes. The first is the initializer, this and that. Initializer, they execute on exactly once. You haven't had Indian food, right? Do you eat spicy food in Argentina? I mean, Spanish people, I guess, uh, they Latin people, actually Latinos, they are famous for their spicy food. I heard. In Mexico, they love spicy food. So, what is your take? I mean, do you have spicy food or what? Desugaring. There's a lot of machinery involved here. But on that stuff it does. I think you couldn't do its statements we already have. For loops since but not as spicy as Mexican. Okay. We have real spicy, man. In India you have to be good with spicy food. There are food which aren't spicy, but most of them are. That's what I know. Now there's a lot of machinery, but none have this one. For loops didn't support initializer. You could have just put initializer. Loops doesn't need for loops. They just make some common code patterns more pleasant, right? These are called syntactic super. For example, the previous for loop could be written to something. Mm, some of the nice expression forms by language like follower. Slightly more than a spoonful of sugar. Let's see, there is a picture missing. Cool. This has the exact same, but there's some on the mountains. Even Buenos Aires is a mountainous city, I heard. Suddenly it is flat. Ah, okay. Hey. Leave it to Chile or all the mountains. Okay. Yeah, so that is true. I mean, mountainous people are tend to have a spicy diet. Los Andes mountains. Okay. Instead of directly interpreting for loops, the parser will consume the new syntax and translate to a more primitive form, so the interpreter already knows how to execute. Okay, so cool. In addition, the backend does a lot of work. It's supported semantics. Few of those there are the more mileage it gets out of each explanation. Meanwhile, rich syntax makes the language more pleasant and productive to work in. Desugaring bridges the gap. It lets you take a robust expressive grammar and put down a smaller number of primitives that the backend can do its magic on. One of the previous statements, we wanted a new syntax tree node. Okay, so we straight go to parsing. What we'll need soon. The Antarctica to Amazons. Antarctica to Amazons, really? Isn't there sea in between? Okay, let's see in the Google Maps. Okay. Okay, this is the Los Andes mountain. The satellite view actually. So okay. So this is the mountain range. This is the whole mountain range. Yeah, so it ends here, right? How did it reach Antarctica? There's sea here. Okay, there's the mountain goes underwater. Okay. Oh, there's all mountains here, man. These guys have even mapped underwater sea. Okay, the mountain starts here, right? Okay, this place is the mountains. Okay. Okay, let's see where your home is. Can I see that on the map? Let's go to Buenos Aires. Buenos Aires. Okay, okay, it's near the sea. Atlantic Ocean. Nice. So you do have beaches on Buenos Aires, I guess. We have a part of Antarctica too. Cool. Okay, you have a part of Antarctica too. Argentina. Let's see. Where Argentina leads. Where is the border? Hey, this is the border, right? Argentina. Oh, you have a road here too, up to this place. Nice. Okay, this Chile comes here, and then you have Argentina. I think this is Argentina, right? That's a river actually, it's a fat river. Okay, that's a river. Yes, nice. Okay, let's go to Buenos Aires. Where were we? Aha. Okay, that's a huge city, man. La Plata. What's La Plata? Uh-huh. So, where are you actually? Your home? Vicente Lopez. Vicente Lopez is the name of a guy, it seems. La Plata is city. Where is your home, man? Yeah, I know Buenos Aires. I am in Buenos Aires right now. General San Martin. This is Buenos Aires, I guess, right? Yeah, there, I don't know. Lol. That's cool. Ah, the map. I used to love the map. Posadas. Posadas is a city, I guess. So, Brazil is huge. So, this is the Brazil border, I guess, right? Uruguay is a very small, tiny place. Paraguay is landlocked. Ah, Paraguay is landlocked. Really? This is, I think, Peru, Colombia, Venezuela. Oh, Venezuela's condition is really bad, right? I heard. Guyana, Suriname, and where is Ecuador? Bogota, Medellin, Colombia. Yeah, Colombia is famous for, you know, Medellin, for all the wrong reasons. But the river is big, so there is some river in. This is Ecuador. Okay, so there's a lot of things here. Uh-huh. Too hot beyond Brazil, lol. Acha. Yeah, so the weather must be cold in these parts, right? And Brazil is damn hot, I guess. I know. Let's see this map. What is the equator? Equator must be somewhere here. Equator. So you are quite below the equator, actually. To be honest, yeah, equator is here. Not that below. Equator passes through this place, yeah. Mm-hmm. This is my home, India. Look at how fucking populated this country is, man. It's like damn populated. You'll be surprised. This is where I live in India. This is the mainland kind of India part. This is where I live. So we have a beautiful river that is flowing through a huge river. This river. You'll be surprised how huge this river is. It flows through the Indian Ocean, and this is how huge the river is. Now, in this river, there is a river island. You'll be surprised at that too. But I'll show you actually how wherever the river island is. So we are doing maps here. Yeah, I think that's the river island, right? Majuli. Where was Majuli, man? Mountains on the north too. Yeah, there are mountains. So I have mountain. Even I have hilly area, hills just beside my house. There is a waterfall beside my house that comes from the hills. So there's some Kirchik 95 guy. Hi Kirchik. I do not think this guy is a bot guy or girl. I don't know. Somehow it's offline. Okay. Hello. So, hi Kirchik. I'm online. Okay. So how come you are here? Welcome to my stream. Let me be clear. I do this stream just to meet new people. There's no like showing off my coding skills or trying to earn money here. So yeah, I mean just to have conversation with people. Yeah. What about you? Tell me what do you code in your front end, back end? Okay, so this is my place. Yes, cool. Where were we? We were writing interesting people who is using Vim and Vim for coding. I'm a front-end developer from Russia. Haha, Russia. So we are just exploring maps actually, me and Juan. Juan is also in the chat right now. So yeah. Where are you from, Russia exactly? Russia is a huge country. I know a few places. I mean, just from general knowledge. Crimea. Crimea. I know Crimea. Okay, so the leader, I think the guy who runs Crimea. Did I pronounce it right? It's private. It was a private. Yeah. Actually. So there was one guy that ran Crimea, I guess, right now. He's a leader or something. I forgot. Anyways, whatever. Crimea, nice. Oh, since 2014, it's a Russian. Oh, the Crimea is famous for that war that was going on, right? I forgot about it. I'm just curious to know. Because I have heard that place name many times in the news or somewhere else, I don't know. Okay, so here we'll write parser. We're not very interested in this. So parser, let's go how. So we'll import the arrays. On the bottom of the news, they were talking like Russia invaded and forced to become part of Russia. Yeah, exactly. That's what I heard. What's the reality? Speaks Russian and they were happy to become a part of Russia. Oh, nice. Actually, the people for. Actually, in the news, Russia is always vilified, made as villain. That's a very bad reality. I mean, many a times we do not get to see the real news. And this is all due to US's influence on the whole culture of the world actually. That's a very bad thing that happens, but okay. Anyways, we are programmers, we do not care much about those things, I guess. The problem for Crimea is that US and Europe sanctioned Crimea. Okay. My day starts with turning on VPN. So I feel sorry for you, man. Okay, so you are a front-end developer. You got 2 times. Oh fuck, man. Oh, so you have something called Gitia, right? I have a very good friend in GitHub from. That guy was from Russia, I guess. I don't know. Yeah, you have Gitia, right? Written in Go. Okay, it's a GitHub clone, I guess, completely. So can I make a repo or it's self-hosted? Careful. No, it's okay. So why did you get banned? I just wanted to know. I mean, why did you get banned in GitHub? I mean, what did you actually do? Apart from the VPN thing, obviously. So we consume the left parent first. GitHub is now owned by. Oh, okay. Okay, you guys feel the impact of Microsoft then. At first, it was an independent organization, and like it is okay. Those people did not care for these things much, I guess. So you guys also cannot GitHub education pack, right? You guys cannot. Fuck, man. Acha. No, okay. So I was reading the terms and conditions of GitHub student developer pack. They were saying that they cannot provide this development pack to students from a few countries or places. So I heard about that. I'm not sure. Yeah, that's an unfortunate thing to happen. By the way, so same in Cuba, Iran. Yeah, exactly. I mean, the US has a very bad repo actually. I am not a very big fan of the US. They are like doing unnecessary thing all the time. So recently, you guys might have heard Iran, Crimea, Pakistan, and a few more. Yeah, exactly. So recently, you guys might have heard that GitHub master is going to be changed to main. It was so cringy thing to happen, man. You guys are like, we own the thing and we'll do whatever we want to. GitLab was there, not hiring people from that countries. Okay. GitLabs. All these things master to main. So we have force treatment. Changing our focus. Yeah, exactly. That's the whole thing. Changing our focus actually. Publicity stunt. It's a publicity stunt. That's it. Anyways, lots about US. Tell me more about yourself, man. You say you are a front-end developer. That means JavaScript and JavaScript. Why did you end? Okay. Why did you end up in my stream? Anyways, it's nice. Welcome. Okay, so first for initializer equal to fire declaration, or else what do we have? Initializer equal to expression statement. Okay, can you do that? Okay, there is still support for comma. Fire declaration. Okay, so you might be on my network through a VPN, I guess, because Twitch is also American, I guess, right? Twitch is American or not? Let me see. Twitch, there's a billing form. I do not even know if I'm whether the thing I'm. Oh man, it must be. Twitch is subsidiary of Amazon. Right now Amazon bought it, I know. It's where this fucking thing is from. Okay, so this is working with rare. Okay, reduction next. Cool, nice. I mean, I have also worked with React for 3 years maybe. Yeah, it's been 3 years, professionally and personally both. I have worked with React a lot. I was a big fan of React until I started coding in Svelte. So there's a framework called Svelte. If you want to check it out. So Svelte, then I completely shifted to Svelte. I mean, like, at least for front end. Yeah, actually Svelte is very cool. In fact, like, it's one of the best languages I've ever, not languages, I mean the whole framework thing. It's very easy to understand and be on the same stage with React, Vue, Angular. Yeah, really. But I have shifted my focus actually for front end at least on Svelte. I like their approach of things to make everything very simple. React is unnecessarily complicated at times. Plus, it's not very performance friendly also. For statement. The for statement initializer, and we have token following the semicolon, and the initializer has been omitted or the check. Error statement, declaration, and there was a message an expression we passed that. Cool. And the previous has to be the split expression and syntax trees into 2 separate class varieties. Because there's I guess. Okay, let's start with the condition. We have some conditions here after this, obviously. We have 2 conditions actually. The first one is they didn't put the condition name. So yeah, obviously we check semicolon. If it's there, condition. Sorry. Yeah. I have to go. Yeah, cool. Bye. Thanks for coming, man. Crimea guy. Oh man, I've never thought I would ever talk to people from so many places in the world. good. So what we do is consume things. Condition is null. Consume semicolon. Expect after loop condition. So we consume the semicolon or else we return a error, obviously. So now after that we have the incrementer, increment condition. What does increment do? Increment is generally something that right parent, this is the parser, right? Okay, increment equal to expression and we consume. This guy has made all of this thing very simple. Expect. Okay, it will take a lot of time for me to get this hold on together. Similar to the condition. Okay, just me or does some orbit similar to the condition clause, except this one is terminated by the closing parenthesis. Okay, all that remains is the body. Is me just or does it sound morbid? All that remained was the body. Okay. So we consume this shit out. Now body is simple, body is just a statement. Okay, we only write the body or what? What about the increment and everything? Something, whatever the clauses we passed, this is where desugaring comes in. We will take those and use them to synthesize syntax tree nodes. Okay. Okay. If increment unequal to null, okay, we are desugaring this thing, so we have body equal to dot as list. Okay, we are first putting the first thing in the body. Second thing we are doing is increment. Okay, second thing we are doing is the expression and the increment. We have the body and the increment. What about condition? Doesn't seem to be used anyway. Increment, if there is one excludes the body after each iteration of the loop. We do that by replacing the body with a little block contains the original body followed by an expression. What's the increment? Shit. Okay, now if condition equal to null, so if the condition is null, condition equal to new. Okay, so what this does is condition equal to null, increment is null, and what equal to something, condition is something after the implementation. Now body is new stmt dot while condition body. Okay, so we have a condition and body. Okay, so implementation happens. This is a very nice syntax, Sugar. So this has been converted to a while loop here. Nice, very nice, very nice. But what about the initializer? Okay, let's do some initializing. Conditions if initializer unequal to null, so body equal to new okay, I got it. Okay, so we have something here. Let's write it in our logs file. There was this logs file we had. Yeah, there's an in code. A1. So we have B1. B1. So we have, so this is done. For loops. So future responder will support first class functions and dynamic dispatch. Then we technically won't need branching statements built into this language. Show how conditional execution can be implemented in those terms. I mean, yeah, obviously, that's functional things. Name a language that uses this technique to control this flow. Haskell, maybe? Do you know of a language? Name a language. Likewise, looping can be implemented using the same tools, provided our language supports, interpreter supports an important optimization. What is it is and why is it necessary? Name a language that uses this technique for implemented using the same tools. Same tools means okay. Some memoization happens. It's good. Iteration, memoization happens obviously. Unlike logs, most other C style languages also support break and continue. For loops in Haskell, I think it's Haskell, I guess. Where are the for loops? Yeah, where are the for loops, man? Cool. So there is no for loop. Have you done Haskell? I have to do Haskell someday. When people have heard that's one of the, yeah. Have you done that Haskell? I mean, it's a very tough language. I heard. I mean, tough to at least get it, how it's working and everything. Unlike logs, most other C style languages also support break and continue. Okay. The syntax is a break keyword followed by a semicolon. So it should be a syntactic error to have a break statement appear outside of any enclosing loop. At runtime, the break statement causes execution to jump to the end of the nearest enclosing loop. Proceed from there. Now that the break may be nested inside other blocks. Okay, and most of the add support for break statements. I have to add support for break statements in my language. Okay, so when you design your own language, choose how much syntactic sugar to pour into your grammar. Don't make a unsweetened health food where semantic operation next to a single syntactic circuit. Innovate all points that we contain. On the extreme message side of the root, the minimal syntax like list part. These first famously came their language with no syntax, while small talkers proudly show how you can fit the entire grammar into an index card. Okay. This tribe has the philosophy that the language doesn't need syntactic sugar. Instead, the minimal syntax and semantics it provides are powerful enough to apply in code basis. Near or there, these are languages like C, Lua, and Go. They aim for simplicity and clarity over minimalism. Some like Go deliberately eschew both syntax sugar and the kind of syntactic extensibility of the previous criteria. They want the syntax to get out of the way of the semantics, so they focus on keeping both the grammar and library simple. Code should be more obvious more than beautiful. Somewhere in the middle you have languages like Java, C#, Python. Eventually, if you reach Ruby, C++, Perl, D, languages which have stuffed so much syntax into the grammar. Yeah, that's true. They're running out of punctuation characters on the keyboard. That's very true. To some degree, location on the spectrum correlates with age. It's relatively easy to add bits of syntactic sugar in late releases. New syntax is a crowd pleaser and it's less likely to break existing programs than mimicking the semantics. Once added, you can never take it away, so languages tend to sweeten with time. One of the main benefits of creating a new language from scratch is giving the opportunity to scrap those accumulated layers of frosting and start over. Nice. Syntactic sugar has a bad rap among PL intelligence. There's a real fetish for minimalism in the crowd. There's some justification for that. Poorly designed, unneeded syntax raises the cognitive load without adding enough specifics to carry its weight. Okay. Now, since there is always pressure to cram new features into the language, it takes discipline and focus on simplicity to avoid block. Once you add some syntax, you are stuck with it, so it's smart to be parsimonious. At the same time, most successful languages do have fairly complex grammars, at least by the time they are widely used. Okay. Programmers spend a lot of time in their language of choice, and a few niceties here and there can improve the comfort and efficiency of their work. That's true. Choosing the right level of sweetness. Okay, so we have this done if and else conditions. We have functions here now. That is also the way the human mind works, by the compounding of old ideas into new structures that become new ideas and can themselves be used in compounds and round endlessly, growing ever remote from the basic earth. On imagining there is each language soil. The accumulation of the previous chapters add these functions. Real-time user-defined functions and function calls. Nice. Cool. We'll have functions now. Really? After this. Okay, so Java part is implemented. I think it will work. Anyways, I'll test it out in nim. Let's implement the nim part now. Before that, what I want to do is take a small little break. 10 minutes. I'll be in 10 minutes. do a put script here. Adds a lower clock source which it was animated. Okay, the property is available. An animated analog clock. So can I put a script here? I'm not sure. Yeah, lower clock. I can put it here. Okay, no properties available. So this is my time. I will be available in maybe some countdown time. Till 3:30 am IST. Okay, so this is now.
सहिलो हुन्छ भने त फाल्टुको त क्यान्सल गरिराख्नुपर्छ नोट जेस किन युज गर्नु चाहिँ तपाईँ उनी ब्याकएन्डै त चाहियो त म थोरै न मैले त जेको अलिकति साह्रो लाग्ने क्लास के हुन्छ क्लास भेरी इजी छ उसले पनि क्लास जान्न चाहिँ होला क्लास त बहुत इजी छ क्लास सुनेछस् नि बहुत इजी छ इन्टिग्रेट के गर्नु खै त इन्टिग्रेट पनि आउँछ के इन्टिग्रेट गर्नु त्यसलाई इन्टिग्रेसन के गर्दैन त्यो पुरा सेपरेट एन्टिटिज हो दुईटा
होल एउटा एप्लिकेसन बनाउँछ त्यो इन्टिग्रेटेड एप्लिकेसनमा के हो इन्टिग्रेटेड टिकेटर युज गर्नु म टेक्निकल त इङ्ग्लिस बहुत राम्रो छ
त्यो इन्टिग्रेट भन्दैन
इन्टिग्रेसन इन्टु वान होल एप्लिकेसन
ठिकै छ बुझेको छ
स्टैक टेक्नोलॉजी स्टैक एक्सपेरिमेंट गरेर पहिले आइडिया समेसन त्यसमा के लेख्न सकिन्छ नि त युजर एक्सपेरिमेन्ट गर्नुपर्छ के गरिन्छ गर्नुपर्छ
somewhere to 3:30 AM.
So something went on and got played. Okay. Hello. 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 So let's go to screencast. Okay, I'm back. And I just want things to be a bit. That's it. That's it. Okay. So yeah, audio input, we have desktop input. 27s are 0. See, these are also 0. Almost, I guess. Yeah.
get it when we bite into an apple or imagine.
So this guy talks about brainwaves.
And for a brief period, a split second, was the time. It's not during their meditation. Never seen it before. We asked them, for example, to do a meditation on compassion. Olympic level meditators, when we asked them, for example, to do a meditation on compassion, their level of gamma jumps 700 to 800% in a few seconds. This has also never been seen by science. So we have to assume that the special state of consciousness that you see in the highest level meditators is a lot like something described in the classical meditation literature centuries ago, which is that there is a state of being which is not like our ordinary state. You know, sometimes it's called liberation, enlightenment, awake, whatever the word may be. We suspect there's really no vocabulary that captures what that might be. The people that we've talked to in this Olympic level group say it's a very spacious sense, wide open. You're prepared for whatever may come. We just don't know, but we do know it's quite remarkable.
Okay, so we have, I think, someone else. Electrical, no. Or these are all bots. Lao Tzu.
चले
Yeah, this is something I have to do.
Does your app need a way to send users to external URLs, either to a web page or to send an email or even sometimes to a phone number? The URL package is for you. For example, opening a web page on a button press is as easy as calling a single method. You can also use the URL launcher with telephone numbers. This will start the phone's dialer app. Or you can initiate text messages, or even emails. Finally, if there are apps installed with special URL handlers such as YouTube, your app can launch into those apps. One last thing, you should always look before you leap. Make sure to call can launch to check if the device can open the URL, otherwise you might run into trouble. For more details and instructions on including this functionality in your app, check out the URL launcher package on pub.dev.
Really, this is a good thing. I should do more Flutter development. Okay. Oh. issue. JP Morgan says now. Okay, so we'll write this in name now. Cool. Is this charged? Okay, no more time wasting now. Okay. So I have this actually. Anyways, I'll be here for the next 2 hours, I guess. So that should be good. For 3 hours till now. Cool. Okay, so control flow. So what's a control flow? Now, first of all, let's see what's a control flow. Put in the channel. Channel is a channel here. Alternative. Okay, anyways, control group. Sorry, evaluation and everything. But compared to last chapter's scaling marathon, still write a JSON process first. Okay, we have written some things in Java. I think things should work now. We'll write these things in Vim. Okay, keep this brief. Test our thing now where we made changes to expectation. What changes to? Let's see. We made a few changes. Now expression statement has a few expressions. Assignment. Expression has an assignment. Fine. Oh, sorry. Speaker. We can get on the expression part. Now, the new expression logic or logic and. So we have two expression logic or and logic and. So yeah. Okay. Superman. Patience, so we have logic and So this is done. So we have a few statements also here now. If statement for state in statement there is a condition that is an expiration, and body that is an statement, first statement. And there is a body. Expire statement. Okay, so for has a few things up here. While has what is while is expiration and body. It's simple. While like if as an expiration, and the body. Okay. Now we have this spread out for us. Okay, so I think there is no error here of any kind. Now let's move on to our Java counterpart. Yay, Java, not so yay. I hate Java anyways. Mm-hmm. Okay. Okay, it's crashing. It's crashing. Due to some reason. Written in class.
And Vim LSP, is it out? Okay, so we have a few LS. Mean LS. The intelligence.
Oof.